All right, good morning, everybody. Get started. You know, we always start with a warm-up, and the warm-up just reviews what we've been doing from the previous lesson or for the week. All right, so I'm going to share my screen now, guys. All right, so your warm-up is on the screen. Waiting on me to say good morning. I'm going to go to the next concept that we did yesterday. So we have a two-part warm-up today. We have a two-part warm-up today. So that's the first part of it. Remember, you're supposed to, step one, label your triangle. Label. Step two, identify the correct trigonometric ratio. Step three, write the ratio out. Step four, substitute. Step five, solve. All right, I'm going to give y'all one more minute for the first one, and then I'm going to put that answer up. Let me label while I kill the time. All right, so this is, here's another thing that I wanted to share with you. As much as we say to students that you need to learn that, teachers are always learning. So I realized in just doing these lessons with you that not labeling the side that's blank really, it causes you to identify the trigonometric ratio better. So I'm not going to label this side here. I'm not going to put anything there because I don't need it. I'm going to label the sides that I need, okay? So this is the opposite side, and this is the adjacent side. So that's going to help you. So now you're going to look for the trigonometric ratio that uses O and A. All right, so let me put my answer in. I got that y is equal to 10.5 centimeters, something that we just did yesterday. So the first thing we're going to do again, guys, is we're going to label. I'm going to ignore RQ because I don't need RQ. I'm going to label PQ, which is my hypotenuse, and I'm going to label my adjacent side. Then I'm going to look at the top where it says SOHCAHTOA, which trigonometric ratio tells me that I need, which trigonometric ratio tells me, uses adjacent and hypotenuse. Come on, I see the answers coming in. I want some more of you to answer me. Morning, Jason. Good. Cosine. So I'm going to write out the ratio. Cosine of theta is equal to A over H. Cosine theta represents the angle. I don't know the angle, so I'm going to put in P. That's the angle they're telling me to find. It's equal to the adjacent side, which is 17. I'm substituting now. It's equal to the adjacent side over 25. Now, we are solving for P. When you are solving, you perform the opposite operation on the opposite side, so you can isolate P. So the opposite of cosine would be cosine inverse. All right. So the cosine inverse of 17 divided by 25. I would have said to you yesterday that you don't have to divide 17 by 25 and write the decimal out. I don't teach that method because I just feel like my students can sometimes make a mistake in writing the decimal out. Most calculators, you can go ahead and just put it in as is. If you have a small screen calculator, in most cases, it's a small screen Texas calculator. The calculator only has one line on the screen. You have to put 17 divided by 25 and then press second function, then press cosine. If you have a big screen calculator, you press second function or shift, and then cosine inverse shows up on your screen, and then you put 17 divided by 25. And that's usually the Casio, the Canon, the Helix, and some Texas, not all, it depends. All right, remember now, they say they want this to, I see people giving me a lot of the wrong units. You have to be careful with your units now because this is an angle. Angles are measured in degrees, all right? So my answer is going to come up. Remember, they say they wanted your answer correct to 1 decimal place. So I got 47.2. 47.2 degrees. It depends on your calculator. I think you may have a calculator where your bracket has to be closed, less linear. I think that may be the case. If it's not that, then it may be that you're putting it in as a fraction and not a decimal and not division. 17 divided by 25. All right. Another, because I notice some more of you are here now. I think it's going to come up on the screen anyway. All right, so we're into our lesson, trigonometric ratios. In here, I am Mr. Shanton knows I am the presenter, but I am in here, or you are in here with Mr. Hall, Miss Newbold, Miss Penn, and Mr. Valentine. They are the persons who respond to you in the chat and in the Q&A, okay? So like I said, you got a lot of help in here, guys, okay? All right, at the end of this lesson, students will be able to use trigonometric ratios to solve real life problems, all right? So we're gonna take what we've been doing and put it to the real world now. All right, solving word problems using trigonometry. Step 1, you have to draw a diagram. You must start with a diagram, okay? Draw a diagram. Then you're going to label the diagram with side, lengths, and angles. So you're going to put in the appropriate measurements where they should be. Then you're going to label your hypotenuse, your adjacent, your opposite side. 4, you're going to pick the right ratio and then write out that ratio. You're going to substitute and then you're going to solve. Last but not least, you're going to answer the question that was asked. I'm going to say it again. 1, draw a diagram. 2, label your diagram with the appropriate measurements where they should be. 3, you're labeling hypotenuse, opposite, and adjacent. 4, pick the appropriate or the correct ratio and write out the ratio. You're going to substitute the ratio and then solve. And lastly, you're going to answer the question that you were asked. All right, let's get into our examples. All right, first one. A ladder is placed against a wall such that it reaches the top of the wall at a height, I think that says 6 feet, and the angle formed with the ladder and the ground is 60 degrees. Find how far the ladder is from the foot of the wall. Now, if you did Pythag with me, you would remember, us doing a side view of this ladder question. When you look at the ladder and a wall from a side view, it almost gives you the shape of a right angle triangle. So I'm going to bring my diagram in now. All right, so that's my wall, that's my ladder. Good. Now, they have some important stuff in there for me. Let me highlight. So they say a ladder is placed against a wall such that it reaches the top of the wall at a height of 6 feet. 6 meters, sorry, I couldn't see that. And the angle formed with the ladder in the ground is 60 degrees. Find how far the ladder is from the foot of the wall. That's what I'm finding. So let me erase this last part of it. So they're important. Like I said, my diagram's up. And now I'm going to start to put in my important information. So I'm going to put in my 6 meters first. Is that going in the appropriate place? Yes, because they said the The height of the wall is 6 meters. So the ladder touches the wall at 6 meters. Everybody agree with me? Did I put that in the right place? Remember now, when you're doing this, you have to make sure you're putting the information in the right place. And I should have jumped to that. I should have let you help me through that. But anywho, the angle formed with the ladder and the ground is 60 degrees. So we got to talk now. Is it going to go? Is it going to go here? Or is it going to go there? So I'm going to call that one A. I'm going to call this one B. Where does 60 degrees go? At A or at B? At A or at B? Good, good, very good. I see some new names. Good, good. Somebody's in here as anonymous. Please don't come into the chat as anonymous, okay? We don't want anybody in here as anonymous. So if you cannot leave and fix it now, do not come back in this classroom as anonymous. All right, so we're gonna use B because we're gonna make the very educated guess that this thing at the bottom here is the ground. All right, so it's gonna come in now. That's my 60 degrees. Let me erase. Oh shoot, it's the ground gone, but that's okay. That's my 60 degrees. All right, so I did step 1. I drew my diagram. I did step 2. I put in the information that they gave me. What am I gonna do next? What am I going to do next? Label. Okay, good. I'm going to label my sides. Remember, I said that I noticed that it's easier to just label the sides that you need. But we don't necessarily, we're missing something. We don't know what side we're finding. Can anybody tell me what side they think we're finding? Where should my unknown or my X go? They say they want to know how far is the ladder from the foot of the wall. Where is that going to go? Where's that gonna go? Interesting. All right. All right. So I'm saying hypotenuse. I'm saying on the ladder. I'm saying at the ground. Let's read that again. How far is the ladder from the foot of the wall? That's the question. Just making sure. All right. So let's look at it. Get my spotlight. Good. Does this represent that? Does this distance from here to here represent that? Yes or no? This distance from here to here, does this tell me how far the ladder is from the foot of the wall? That's what, notice that says foot of the wall. Okay, good. No, it doesn't. This is actually my ladder. So it just tells me the distance. This would represent the length of my ladder, how long my ladder is. What about here? Does this tell me now, this is the foot of the wall, this is the foot of my ladder, is I'm finding? Yes, it is. Very good, very good. So I'm gonna put an X there. Good. Now I'm going to label, and I'm only gonna label the 2 sides that I need, the 6 meters and what I'm finding. That's the opposite side, and this is the adjacent. So I did steps 1, 2, and 3. Which trigonometric ratio uses O and A? Notice I got it beautifully placed in the corner here. Very good, Maya. Excellent, Alexander. Good. Very good, D'Angelo. Good, Selenko. Good. We're going to use the tangent ratio. Good. So I start by writing my ratio. Now I'm going to substitute. I'm going to replace. I'm going to replace this thing here, which is called theta, with what number? What's going to go there? What's going to go there? Theta. I'm going to replace theta with what number? Very good. Theta represents the angle. So I'm going to put the angle there. So tan of 60 goes there. What's the opposite side? What goes where O is? Very good, very good. 6 goes where O is. Excellent. And what goes where A is? X. I just want to make sure you guys, you have to substitute it correctly. Now, we in a little bit of pickle. Why are we in a pickle? What's wrong? Or what's a little bit peculiar with this situation? We recognize that when your letter is in your denominator, you need to do something called divide. So what we said yesterday is we'll simply swap x and swap the tangent of 60, okay? That's what we did. When your x is in the denominator, you switch the 2 out. So you just swap them, okay? And that sets up your equation the way you want, and now you can work it out. So in your calculators, you have a little screen calculator. You're going to put 6, then 60, then, 6, then divide, then 60, then press tan, and then equal. Little screen calculator like the text is 6, then divide, then 60, then tangent, press equal, okay? I rounded this one, I think, to the nearest whole number, because I did them differently. Good, very good, Britannia. If you have a big screen calculator, you put it in as you see it. 6 divided by tangent of 60, nearest whole number. Good. All right, so I got 3.464. Remember I said to you last week, the nearest whole number means that you're talking about dollars and cents. So I have $3.46. I want to round it to, I want to talk about my dollars only. I got $3, okay? So the answer is 3 meters, and I have it, nearest whole number, but I rounded to. And lastly, I answered the question. The ladder is 3 meters away from the foot of the wall. You have to answer the question that's asked. All right, so let me clear all, and let's move to the next example. All right, so the next example says a string of a kite is 100 meters long and it makes an angle of 40 degrees with a horizontal view. Find the height of the kite, assuming that there is no slack in the string. All right, so I'm going to just do this just as an extra step, and you really should do this in solving all word problems. The 100 meters long, because that's the string of the kite, the angle with the horizontal view, and they're asking me to find the height of the kite. All right. So I did that. Next thing, I need to, what do I do next? Because I can't figure out where these things gonna go just off of, you know, reading it. What do I do next? Good, I'm gonna draw a diagram. Very good. So here comes my diagram. All right, so that's my kite. That's the string to hold my kite, because we know our kite doesn't go upright, it'll go at an angle. All right, and then I end up saying, okay, this up down thing is my, what they call vertical. That's a vertical distance, okay? And then I have my horizontal distance, or my horizontal view, okay? Next thing, I'm gonna put in my values. Where you think the 100 meters gonna go? Where's the 100 meters? Think now, they say the string of my kite is 100 meters. Where's the string? Where's the string? Is this the string? Is that the, good. So the string is the hypotenuse. That's where the string is gonna go. That's 100 meters, okay? And then where does the 40 degree go? I think I sort of kind of gave that one away, but anyway, where does the 40 degree go? Excuse me. Where does the 40 degree go? Remember that that's an angle. The 40 degree goes in the same yellow space right here. Just wanted to, good, very good, excellent guys, because that's horizontal. All right, and if you were to, and we're gonna get into this next week, and I intentionally didn't want to do it today because I know I want to start it fresh on Monday, and it's not a challenging concept, but if you want the angle measured from looking straight ahead to looking up at the string, the degree formed in there is 40 degrees. I know some of you know what it is, but I'm not gonna say. What are they asking me to find? What are they asking me to find? Where's that gonna go? What are they asking me to find? Where's that gonna go? Good, Latasia. Height. Where you think that height gonna go? Is it gonna be here? Or is it gonna be there? Up and down or across? Up and down or across? Up and down or across? Think of height. And you want to know how high or how tall somebody is. Where they're gonna go? Good. Most of you got it. We're gonna go up and down. Very good. All right. So I'm gonna put in my X there. Now I'm gonna label. Remember, we only labeling the two sides we need. So that's opposite, and this is hypotenuse. Good. Which trigonometric ratio uses O and H? Why Maya, you want it? Good. Good. Very good, Shakonya. Yes, yes. We're using sine. All right. So now we're going to substitute. We got our formula in. We're going to replace theta with 40. Replace O with X. And replace H with 100. All right. 100 is at the bottom. So am I going to divide again? No, very good. I'm not going to divide. I'm going to multiply. Good, because I'm going to do the opposite operation, the opposite side. I think I rounded this one to 1 decimal place. I'm not sure. Tell me what you get. I think I rounded this to 1 decimal place. If not 1 decimal place, 3 significant figures. I can't remember. Good, good. All right, so we rounded to 3 significant figures. We talked about this. A significant figure is any non-zero digit starting at the left. I round all of these differently, Salinko, okay? Because I wanted us to just review rounding again. So I rounded to my 3rd significant figure, which is 2. Behind the 2 is a 7. So that means that my 2 turns to a 3. All right? Lastly, I need to answer the question. The kite is 64.3 meters high. All right. Last example. Let me clear all first. A ski is going down a slope that measures 7,500 feet long. By the end of the slope, the skier has dropped 2,200 vertical feet. To the nearest degree, what is the angle A of the slope? All right. So I missed and put that in there. But anyway, let me highlight. So this is 7,500 feet. Uh-oh. Sorry, guys. All right. This is 7,500 feet. Going down a slope, that's important, and drop to 2,200 vertical feet. And I know that I'm finding, oh, this is to the nearest degree. I'm not sure if I did that. I'm not sure if I rounded to the nearest degree. I'm finding angle A. All right. So there's my skier coming down the slope. Now, where does the 7,500 feet go? Where does the 7,500 feet go? The adjacent is. No, we don't. Okay. So most persons said where the skier is. That's correct. So 7,500 goes there. Where does 2,200 go? Does it go up and down or does it go across? Up and down or across? 2,200 vertical feet. All right, good. Up and down. Perfect. Now they're asking me to find angle A. I'm going to put that in for you because that could be a bit tricky when they talk about, you know, slopes. I put in the angle A. So I have my information incorrectly. I'm now going to label. So I put in my hypotenuse and I put in my opposite. Which trigonometric ratio am I going to use? Good. I'm going to use sine. Sine. Good. So I bring up my formula as I should. Next step would be to substitute. Now, I don't have a theta in this case. I have, what's the angle going to be? It's not going to be theta, and I don't have an angle. So what's going to go there? What should go there? Good, Rakia. Good, Janae. Very good. Good, Laura. Good. Excellent. I'm going to put A there. Very good. And then I put in my opposite and my hypotenuse. Now I'm finding my angle. What do I do when I'm finding the angle? I reviewed it at the beginning of the lesson, but I want you to tell me. All right, so remember, another thing, remember I said we do the inverse of the opposite operation when we try to isolate or solve for something, okay? So I'm solving for A, I want to get rid of the sign, okay? Opposite of sine is sine inverse, okay? Opposite of sine is sine inverse. All right, so that's what we did. And we can put it in our calculator as is. Now, this is saying to the nearest degree. So that means basically the nearest whole number. I don't think I did that, though. I think I did 2 decimal places. All right, so I got 17.057. So the 2 decimal places is 17.6 degrees. I didn't answer the question, I will admit. That's very good, D'Angelo, you are correct. Lastly, the slope is 17.6 degrees because it's an angle, okay? All right, so, and that's basically our whole solving word problems, some of it. On Monday's lesson, I really don't want you to miss Monday's lesson because I'm going to add to solving word problems. We're going to talk about angles of elevation, angles of depression. I really do not want you to miss Monday's lesson. Monday, math is at 9 a.m. in the morning. I think it's at 9 a.m. Be there, please, okay? Let's clear all, and I got a treat for you all today. Before next week's lesson, guys, I still want you to go back and I want you to review, especially if you know you don't quite understand what's happening. I think yesterday's lesson would be a really good review for you. Thursday's lesson would be a perfect review for you because I know it wraps up everything. Make sure you check the site over the weekend because I know we're supposed to be having some timetable changes. So make sure you check the site. I really don't want you to miss Monday's class, all right? Here's my treats. We're going to do a BGCSE question. All right. So it says the diagram shows the cross-section of a roof. DC is equal to 3.6 meters. BD is equal to 2.9 meters. And angle DAB equals 22 degrees. So this is the description that they gave me in the BGCSE question, and then they gave me the diagram. So here's my diagram, all right? Now let's read the rest of my question. Calculate, giving your answer to 1 decimal place, and it has 3 parts. Part A, the length of BC. Part B, the length of AD. And part C, the angle BCD. Now, so if we look at this carefully, I got 2 right angles in there, okay? So I'm going to just show you how to effectively attempt and complete this question, all right? So let's get started. So we're going to calculate part A. We're going to do section by section. Part A, calculate giving your answer to 1 decimal place. Again, my diagram is going to come up. All right, so what I say to my students is, right, when you get a question like this with multiple right angles in it, you need to focus on the angle that speaks to what you're solving or answering at the time. I usually tell my students to take out the angle. But you know, since I'm using technology, I can get all fancy. And I'm going to highlight the triangle that I'm focused on. But I'm going to say this to you. I am going to call out. So I have 2 right angle triangles in there. One is BCD. And then the other one is, I think, ABD. So it's asking me to find BC. What triangle you think I should use, or I've almost always seen them give you a double right angle triangle. So you get two right angle triangles in each question, right? So you need to know how to pick what triangle to focus on. Okay, so most of you are correct. We're going to focus on BCD because that triangle has BC in it. Is BC a side or an angle? Is BC a side or an angle? All right, BC is a side, okay? It's a side. How do I know it's a side? Because it only gives me two letters. So that tells me the distance from B to C. That's what that means. If they wanted you to find an angle, they're going to give you three letters or one. B to C doesn't speak, so I don't even know which angle I would be focusing on. But I know that I can focus from this side, from the letter B to the letter C. So that is a side, all right? So watch my fancy graphics now, okay? I went all out, I think. Yeah, right. Okay. So that's the triangle we are focusing on. We're only going to focus on that. Typically, I would say to you to draw it on its own, but because I'm using PowerPoint and I can highlight it easily, I did that. Now, we got to notice some things. What do we have? Tell me, what do we have? What do we have? Okay, good, Rakia. Okay, tell me what else we have. What do we have? Do we have angles? Do we have sides? What do we have? And how many of them do we have? Right, good. So we have two sides and we need a third side. Is trigonometric ratios the perfect thing to use? Or are trigonometric ratios the perfect thing to use? That would it be wise for me to use trig ratios to find BC, this missing side, considering that I have two sides and I just need to find one more? This is an important skill, so I need y'all to tell me. Okay, someone saying yes, use trig ratios. But what do I need for trigonometric ratios? Do I just need sides? Yes, Alexander. Find a side. So I can't use trigonometric ratios. I'm going to say this again. I need an angle to find sides. Okay? I need an angle to find sides. So I have to use what we learned last week. Some of you already said it. I have to use Pythagorean Theorem because Pythagorean Theorem only focuses on sides. Okay? It doesn't speak to anything about angles. So I'm going to label using Pythag. Be careful now. There's no opposite. There's no adjacent. They're only legs because I don't have a reference angle to say what it's opposite and what's adjacent. Okay? So when do you use Pythagorean Theorem? When you're focusing on sides. That's hypotenuse and that's the leg. All right? So next thing, I'm going to now write the ratio, write the formula. Hypotenuse squared is equal to leg squared plus leg squared. Britannia, you're correct. Very good. I'm going to replace 3.6 squared is equal to 2.9 squared plus BC squared because that's what I'm finding. I'm going to work out now. I'm going to work out. So that's 12.96 is equal to 8.41 plus BC squared. I'm solving for BC. So I want to isolate BC. I want to get rid of the 8.41 and the square sign. I'm going to do the 8.41 first, okay? All right. What I did was I did the opposite of add, 8.41, and I subtracted, all right? I'm going to work that out. That's 4.55. I now need to do the opposite of BC squared. Opposite of square would be square root. So BC is equal to the square root of 4.55. All I did was turn it around. And then I wrote the value out. But they told me in the question that they want me to round to 1 decimal place. So that means that BC is going to be equal to 2.1 meters. All right? Let's recap. I got a diagram, a double diagram. I had to pick which triangle I needed to use. Once I was able to do that, I analyzed the situation. What am I finding? Am I finding an angle or am I finding a side? I recognized that they gave me two letters, B, C, which represents the distance from B to C. So that's a side. Then I analyzed again. What did they give me to help me solve this problem? They gave me two sides, and they're asking me to find a third. I cannot use trigonometric ratios because they require an angle somewhere in there. So that won't help me at all, okay? I had to use something that only speaks to sides, and that would have been Pythagorean Theorem, okay? All right, so let's get to part B. We're running out of time now. We have to calculate the length of AD, all right? So again, am I gonna use triangle ABD or am I gonna use triangle DBC or BCD? Tell me what triangle I'm gonna use. Good, Latasia, good to Shay, very good. Good, Tyne, I thought you left us for a minute. Good, Shaquania, very good. I'm gonna draw out that triangle, okay? Because I couldn't highlight it properly to get all the stuff that I needed. Good, Jason. All right, so I'm just gonna duplicate it. So y'all watch me draw it out so I can focus only on that. I put in my 22 degrees. I put in the names. Good. They're telling me to find AD. So I'm gonna label. Oh, sorry, should have gone there. AD represents a side or an angle. Does AD represent a side or an angle? A side, very good. AD represents a side, excellent. AD represents a side. So that means that I have one side and one angle, and I need another side. Am I gonna go back to Pythag or should I move to trig ratios? Good, Shaquania, good to Shay. Good, Latasia, good. I'm gonna move to trig ratios because I have an angle introduced in there, okay? All right, so I'm gonna label according to trig ratios. Now I have an opposite and adjacent because I have an angle. So I have an opposite side. Which trig ratio uses O and H? Sine. So I'm gonna substitute, gonna replace. Notice that I called my hypotenuse AD. I want you to notice that I'm now putting in the name that they're asking me to find. Okay, I'm sorry, Maya, that you can't see it, but I don't know which part of it you're missing. All right, so AD is the unknown and it's at the bottom. When it's at the bottom, what do? We swap. So I did that. Remember they said they want my answer to 1 decimal place. Done. So my answer is going to be AD is equal to 7.7 meters, okay? All right. Last part of the question. Calculate, giving your answer to 1 decimal place, the angle BCD. All right. Which triangle am I going to focus on again? This one is a given though. I'm going to use BCD again. That's a given. So I'm going to go ahead and put that in there. Now, what do I have? I have two sides and they're asking me to find an angle. They're asking me to find an angle. What letter should I go to? I don't have all my sides. Oh yeah, I do. I do have all my sides. Very good, Shaquania. Okay, here's a tip. I don't recommend that you use a value that you found unless you absolutely have no other choice. In this case, I don't need to use that value I found in part 8. So I'm not going to use that. I'm going to use what they gave me, okay? So what letter am I going to go to? I'm going to go to C. C is the vertex of my angle, okay? I'm going to go to C. C is my reference angle. So I have two sides and I need an angle. Trig ratios of Pythagorean theorem. Trig ratios of Pythagorean theorem. Just the fact that I'm talking about angles, you know I need to use trigonometric ratios, okay? Very good. So I'm going to label again. That's hypotenuse and that's opposite. So I'm going to use the sine ratio. Good. All right. Sine of angle C, because that's what I'm finding, is equal to 2.9 over 3.6. C is equal to the sine inverse of 2.9 and over 3.6. I'm going to work that out. C is equal to 53.66, so forth. And I have to round this to 1 decimal place. And that's going to be 53.7. Very good, Latasia. Good. All right. So that would have been my BGCSE question, my 3-part BGCSE question. Again, what are the tips? Well, that's true, Deontay, but I don't want to say that. What are the tips? The tips are, tip 1, identify what you're asked, whether it's a side or an angle. Good. Once you know that, then you need to find the triangle that you're focusing on. Because like I say, they try to trick you. They give you a double triangle in there. Okay? Then what do you do next? Once you know what you're looking for, you go ahead and you pull out that triangle. Then you analyze what they give you and what you're finding. So you then have to determine, am I going to use Pythag or am I going to use trig ratios? Okay? Once you know what you're using, then you label and then you solve. All right? So let's wrap up this. All right, so you're going to answer me in the chat quickly. Pythagorean theorem, Pythagoras' theorem involves blank sides. Blank is given and blank is missing. Pythagorean theorem involves how many sides? How many sides? Good, Deontay. Pythagorean theorem involves how many sides? Good, Eric. How many sides altogether? 3 sides. It's just 3 sides. How many sides given? How many sides are given? Good. And how much is missing? 1. Good. If you want to find the longest side, which is called the hypotenuse, you square it. You should say you square the leg, you square the next leg, add it, and then you square with that answer. If you want to find one of the shorter sides, you square the leg, you square the hypotenuse, and then you subtract, and then you find the square root of it. All right? Trigonometry involves blank sides. Tell me how many sides first. Good. Good. 2 sides. And how many angles? All right. So you get, let me tell you what happens. You need 2 sides because the ratio would say O over H, A over H, or O over A. So that's your 2 sides. One may be missing, but the general concept or the formula has space for 2 sides. It has the filler for 2 sides, if that makes sense. And then it needs 1 angle. So it always says blank of theta is equal to side over side. Make sense? All right. Blank of these will be given and blank will be missing. 1 and 1. Use so, and what's missing in the blank there? Ka. All right. Use so ka. Pythagorean theorem, sides only has 2 sides. You need a 3rd side. And you have 1 angle and 1 side if you need to find a side. And then, or you will get an angle, or you need to find an angle. Thank you. And you have 2 sides. All right. This will be on the website for you guys. Review this and review yesterday's lesson if you are struggling, because on Tuesday, I'm going to add something else to this concept. All right. I want you to go on the website again, check the schedule. I don't want you to miss Monday's lesson. Thank you for being wonderful participants today. Stay safe, be careful, enjoy your weekend, and you will see Miss Knowles on Monday. All right. See you guys later.